Hello. Yeah. नमस्कार दोस्तों, वेलकम टू गेट वाला। हमारा लेक्चर नंबर 4 या any buffering issue? इस ऑडियो वीडियो सब कुछ क्लियर है? मुझे एक बार कंफर्मेशन कर दीजिए बेटा। ऑडियो वीडियो सब कुछ क्लियर है? जितने लोग लाइव में देख रहे हैं सेशन को, या एक बार वॉइस कंफर्मेशन कर दीजिए। ऑडियो वीडियो सब कुछ क्लियर है? जितने लोग लाइव में देख रहे हैं, चलो। हमने प्रीवियस लेक्चर्स में हमने डीसी ब्रिडजेस एंड एसी ब्रिडजेस डिस्कस किया है। अंडर द एसी ब्रिडजेस हमने बहुत सारा ब्रिडजेस डिस्कस किया है। ओके, मैक्सवेल ब्रिज डिस्कस किया, हेस ब्रिज डिस्कस किया। मैंने बहुत सारा क्वेश्चंस भी करवाया आपके लिए। आप एक बार प्रीवियस लेक्चर्स को देखो। आप कुछ कमेंट्स भी डाल सकते हो उधर, क्या क्या कमेंट्स, कैसा एक्सपीरियंस हो रहा है प्रीवियस क्लासेस का। कुछ डाउट्स है तो डाउट्स भी हम पूछ सकते हैं। ओके डियर, चलो। So under the AC bridges we have discussed the Maxwell. Next we have discussed ACE. Next we have discussed the Anderson. Next we have discussed the Owens. Next we have discussed the DSOT. We have discussed the sharing. Then we have discussed the Wien's bridge also. Okay, so these are the various bridges that we have discussed. Yes, you can follow this video. You can follow this video. You please, I suggest you have to follow the previous lectures also. So अब तक 3 लेक्चर्स हो चुका है, वो लेक्चर्स भी हम देख सकते हैं। ओके, तो 3 लेक्चर्स कंप्लीट हो चुका है, वो लेक्चर्स भी आप देख सकते हैं। एंड आपका जो डाउट्स है वो डाउट्स भी इधर पोस्ट कर सकते हैं, कुछ प्रॉब्लम नहीं। ओके, तो सेमेस्टर एग्जाम्स के लिए भी ये क्लासेस बहुत अच्छा यूजफुल होगा। ओके, जो सेकेंड ईयर थर्ड ईयर स्टूडेंट्स है ना, उसके लिए भी ये क्लासेस बहुत सारा यूजफुल हो जाएगा। चलो, नाउ मैं डिस्कस करना चाहता हूँ उसके बाद टॉपिक्स टू बी कवर्ड। So many topics are there, but I don't know how much we can cover here today. So we are going to cover the measuring instruments today. Okay, so measuring instruments. So measuring instruments के अंदर हमारे पास क्या क्या टॉपिक्स आएगा। So first we are going to get the PMMC, moving iron dynamometer. Okay, so these are the list of the topics that we are going to discuss today. चलो अभी क्लियर है आवाज? या नाउ चेक करो विराज आदर्श, नाउ चेक करो, नाउ कंफर्मेशन कर दीजिए बेटा ऑडियो। अभी क्लियर है? या सो प्लीज मेक ए नोट ऑफ दिस पर्टिकुलर इंस्ट्रूमेंट्स। This instruments information, okay, different types of instruments and इसका working मैंने डिटेल में दिया है, everything has given in a detail। चलो please note down, PMMC stands for permanent magnet moving coil। permanent magnet moving coil, this is suitable only for the DC measurements, so that is one of the expected bit also in IAS exam and GENCO state level exams। so it is only suitable for DC measurements, it is not suitable for AC current and AC voltage because it is not having the mechanism to respond for the different variations of the frequency of the input signal। so इसलिए ये पर्टिकुलर इंस्ट्रूमेंट केवल डीसी इंस्ट्रूमेंट के लिए सुटेबल है, इसलिए हमने व्हीटस्टोन ब्रिज में डिटेक्टर की प्लेस में हमने PMMC को यूज करते हैं व्हीटस्टोन ब्रिज में। ओके, नेक्स्ट मूविंग आयरन इज सुटेबल फॉर बोथ DC and AC, so this is suitable both for DC and AC। next comes the electrodynamometer is also best suitable for both AC and DC। नेक्स्ट हार्डवेयर इंस्ट्रूमेंट्स बोलते हैं उसमें क्या क्या आएगा, हमारा थर्मोकपल आएगा, हाँ ये सेकंड ईयर में होगा, आपका सिलेबस में चेक करो भैया, अगर सेकंड ईयर में फर्स्ट सेमेस्टर थर्ड सेमेस्टर में हो सकता है ना, एक बार चेक करो, आपका करिकुलम चेक कर लो। हार्डवेयर वो हम थर्मल इंस्ट्रूमेंट्स बोलते हैं, थर्मल इंस्ट्रूमेंट्स में हमको क्या क्या आएगा, एक थर्मोकपल टाइप इंस्ट्रूमेंट आएगा, हार्डवेयर इंस्ट्रूमेंट आएगा। So these are suitable for both DC and AC। next electrostatic voltmeter, this is also suitable for both DC and AC। rectifier type instruments, that is suitable for both DC and AC। Hall effect suitable for DC and AC। induction type suitable for DC, induction type is suitable for AC, sorry, okay, this is for AC। so here this is a permanent magnet, in the permanent magnet a current carrying conductor is kept, okay, so this is the conductor my dear। so in this conductor, so if you see this is a conductor, so this is the conductor, so this is our conductor, and this conductor is protected with so these are multiple turns of the copper winding। chalo, so if you see this now, the major thing is the materials। so what are the materials, let us see here। the materials suitable here are what type of materials we are using for the construction of the PMMC। so the materials are, the first one, the permanent magnet, so the permanent magnet, the material is Alnico material, okay, please note down the materials, please make a note of these materials। yeah, now I think now the issue will be gone। So this is with ferrous. Next, the spring, phosphorus bronze, phosphorus bronze. So major thing is the spring here. The spring is like this. The spring is wide and the spring is a ribbon type like this. So it should have Henry, namaste. The spindle is generally made of steel. Okay, so these are the major things. So now whenever a current is passing here, so this is the way, from the way the current is entering. So the current will be entering into this. So when a current carrying conductor is placed in a magnetic field, it experiences a force. So due to that force, it deflects. So the deflection will make this pointer. So there is a two torques here. One is a deflection torque, other one is a controlling torque. So because of the presence of the conductor in the magnetic field, there is a deflection torque. So there are two torques, there are three torques actually. In all measuring instrument, there are three torques. The first one is the deflecting torque. So the deflecting torque I can give with a symbol of TD. Next, the controlling torque. So controlling torque expression is TC, and there is a damping torque. So damping torque T suffix D. Majorly deflecting torque happens because of the magnetic field B versus current. So it is because of the flux versus current. So because of the interaction of flux and current, this particular deflection torque is going to happen. Okay now? Yeah. Yes, working principle of galvanometer. D'Arsonval galvanometer is a derived version of PMMC. Okay na? D'Arsonval galvanometer is a derived version of the PMMC. So controlling torque is generally provided because of the springs. It is because of the springs. Why? Because if only deflection torque is present, the pointer goes on like this. It is not going to be stable. Why? Because if a current of 2 amperes enter, my needle should start 0 and it should settle at 2 amperes. If suppose there is no controlling torque, this needle will move from 0 to the dead end. Do you understand? So that's why deflection torque and controlling torque both should be balanced. But whenever these both are balanced, the pointer cannot come to the settled position immediately. You cannot expect here. I don't know what is this, why it's happening. Yeah. अभी settle हो गया. Torque and controlling torque both are equal. Okay. So this damping. I don't know why it is happening today. Lot of issue is happening. Network. Okay. So here for PMMC, the damping effect is happening because of the D current. So now, if you see the expressions, the deflection torque expression is given by BINA. I'm not deriving that expression. I'm using this expression. So we are not interested in the derivation part here. So what is B? B is the magnetic field. Not important. Derivations are not important for the GATE exam. Okay, derivations are not much important for the GATE exam. So B is a magnetic flux density I is the current passing through the DC current, which is our measurand. This is not important for the gate exam. For your semester exams it is. So this is our measurand. Okay. So this is our measurand. N is the number of turns. A is the area of the coil. L into B. Now it's clear. So आप ऐसा remember कर सकते हैं deflection torque को. So बिना. हिंदी word बिना. तो ऐसा remember कर सकते हैं. ये मेरा trick है. So कुछ skip नहीं होगा. मैंने कुछ भी कुछ ना स्किप किया मैंने. ओके चलो. So this is all about the deflection torque. So this is all about the deflection torque. Now let us go for the controlling torque. The controlling torque is given because of the springs. So controlling torque expression है TC. So controlling torque is TC. TC is equal to Kc into theta. So please note down all these formulas. We are not deriving this expression. Kc is the spring constant, where Kc is the spring constant, where it is the spring constant. Okay, so which can be taken as Newton meter per radian. चलो C and पूरा सा पूरा चलो थोड़ा सा डिस्टर्बेंस आ गया बीच में. So at steady state I can write deflection torque is equal to controlling torque. So deflection torque I can write it as बिना. Controlling torque I can write it as Kc into theta. So this is the output, this is the input. Try to understand. So this is our input current. So this is the output deflection. So on the pointer, so on the dial, we are going to get the deflection. We are going to get the deflection like this. We are going to get the deflection like this. So this theta is directly proportional to current. The output deflection is directly proportional to current. थोड़ा सा. So now if I am taking this theta will चलो. So this theta is proportional to current. So if you see the graph,